with you today. Do you have, let me say a little bit more precisely. Do you have Linux or Mac laptop today? Because for Postgres it would be a little, or for Windows it would be a little bit tedious. But if you have Linux with you or Mac, it will work. If you want to try hacking Postgres yourself, you can connect to Wi-Fi. Here is ICTS Wi-Fi. Open a terminal and find a place for Postgres sources and type git clone https github.com if you are cloning the whole history, it will clone. I don't see my. So you can clone the whole history of Postgres. It's 25 or 30 years of commits. There's a lot. If you want to save traffic and time, you can say single branch. And pick a branch master. And say that you only need like 10 recent commits. That's 10. Right. Anyone needs this comment? Yeah, probably understand something.
Yes.
Yes. Like there was Ingress and then was Postgres. And we can leave it alone. It's very good internet here actually, it's done. Now we have all sources, I always say that Postgres is like, it's text files. It's just text files that are collaboratively edited. And these text files instruct servers how to handle bytes. So I just saw that we need to do it in advance, just in case it will take a lot of time. And let's start from theory. My name is Andrey, probably I saw it. Here's my team. We are mostly based in the engineering work. My team is open source based development team. Also with us here is Max Dubak, he is from a team that is doing database as a service. Peter told us a lot about when we're working with database as a service. It's Max. So, but well, my team is also working for providing components to his team. What we have done recently in Postgres 70, I introduced transaction timeout. For some reason, it wasn't present before I did it. Also, in next months, you will see Postgres 18 with my function for generating UAT v7. I think it will be used extensively to create primary keys. And 2 years ago, I created a sorted index, but our main contribution is actually finding bugs and fixing them. Mostly finding, sometimes fixing. Because our customers, our clients, encounter those bugs, and usually we have to fix something in Postgres to help our clients. Well, we are kind of a cloud, like we are a cloud, but all companies that we do are open source. You can build manage Postgres.com from our components. We open sourced connection pooler Odyssey, we open sourced backup tool, we open sourced sharding tool, we open sourced high availability tool, and at least a dozen of extensions. Everything is available and contributions welcome. There are many users outside of Yandex of these products. So why would you should consider working with Postgres code base? Well, I'd say that most important reason is that it's like your CV. You can prove that you can do something useful, and when you are on an interview, you can even when they are asked about what do you know about databases, you can say, I already wrote some of Postgres. I contributed some of code to Postgres. And actually, that's not that difficult, but it proves that you can write useful code. And Postgres currently is very popular. How to start working on Postgres code base? Well, we kind of started by cloning source codes, but actually, main medium for working with Postgres code base is mailing lists. It's ancient technology for communication, and we still use it. It's just emails. When you are starting to use Postgres, easiest way to get answers to questions is just your admin mailing list. It's a list for DBAs and those who maintain databases. And when you have a problem with your database, you can ask there, or you can see who else has some problem and try to help with your experience with something that you know how to fix. Next list that you can subscribe is just here announced. This is a list where you know that something new happened, something was released. Like there was a new version of Postgres and etc. You cannot send a message to this list. So only moderators can send messages to just get announced, but there is not so many new messages, and I really think that it's a good idea to subscribe to this mailing list. When you have a lot of databases, you are starting the next mailing list, which is called GSQL Box. This is mailing list specifically designed to report problems with your databases that are that obviously need fixes. When you see bugs, you know problems that will be solved in next minor versions, and you know how to properly report problems. You see, well, the databases are a very sophisticated piece of source code, very complex programs, and yet there are bugs. Lots of them per day. And when you report some bugs, you see they are fixed. You see it in Postgres committers mailing list. Every commit to Postgres source code creates a message to this mailing list where you can see how exactly your or someone else's bugs were fixed. You see which branches, which stable versions releases the fixes. You can see commit changes and know what will be there in releases. Sometimes you are not agree with how things were fixed. You see some oversights if you are very experienced with the bugs, and you can see replies to just committers, and this is an open list. You always can comment on how bugs are fixed and how new features were introduced. You can say that, hey, I see there is oversight, and that's valuable contribution actually. And sometimes you see that, like, I think this function lacks parameters, or this this comment can be extended. This maybe this help page can go in different details, and commenting something with GSQL committers actually is a way to create more commits. Frequently, messages to this mailing list can create more commits more frequent than in GSQL hackers. GSQL hackers is a main place where development of new features works, and if you want to introduce something new, you will have to subscribe to GSQL hackers, and this is the most detailed mailing list in the sense that there are at least hundreds of mails a day. It's next to impossible to read everything there, but if you just skim topics, you can see something that's interesting to you and pick some threads where you want to take part. And the most common questions that I get, like, what Postgres is, well, sold. It's 30 years old. And a lot of folks and a lot of bright minds are working on this database. It's still imprecise. You can't help. But most important thing that you can help with is problems that you encounter in your service. You are using Postgres. You see that something is wrong for you. And we call it in the community scratch your own itch. Like, you want to fix a problem that is a problem for you, not for someone else. And that's super important input for the community. Like, you try to call this function and it's failed. You try to index this field and it works slowly. You try to use this SQL query and it doesn't produce the results that you would expect. That's the contribution. And if you want to go deeper, you can provide code fixes for deficiencies that you want to fix. Well, if you really want someone to advise you, do not go to our to-do list, because our to-do list is also old. It's not to-do list. It's a list of ideas that we spend thousands of hackers who attempted to fix them. So it's kind of ideas that are really hard. That's why I do not recommend to use the list. But you can ask for recent, for emerging problems on our Discord server. It's very active. And if you really want to spend a few weeks hacking Postgres, you have a vacation and some time to start with, or your employer told you to start working on Postgres, the best idea would be not just to subscribe to my list, but also to join the Discord server and ask, hey guys, I'm looking for a problem to start, and sometimes experienced hackers advise topics that are not being worked on right now. Well, who is working on Postgres? There is a core team of 7 long-term contributors. Essentially, their role is to intervene if something goes wrong. Normally, they don't try to influence commuters, and development is going just by decisions of commuters. There are lists of contributors, and currently we distinguish contributors and major contributors, but always these lines, who is contributor or who is not listed as a contributor, were, well, difficult, because the code contribution is only a small part of real community work. There are many other ways to contribute, like organizing conferences, or teaching, or maybe helping others on mailing lists, and so on. And because contributor lists have to take into account all ways of contribution, it's difficult to say how to become a listed contributor, but at least now we have a mailing list process. Like when we have a big problem, we have a mailing list process. It's contributors mailing list where there is a contributors committee. Today they define that we list contributors who contribute to core in any way for more than 2 years. I don't exactly understand what is the real reasons there, but it's how it works. We have a list of sponsoring companies, and that's where things start to be more interesting, because if your employer wants you to work on Postgres, they have to pay you for this. They want to be listed here, listed as a company who is contributing to Postgres, and that's another committee for this. We have sponsor committees who assess how much company invested into Postgres development, and places companies here. Commuters. Well, probably you can't read this slide because there are 30 commuters as of today. Commuter decides the patch that you have sent to Postgres hackers mailing list will be accepted or not. If committer committed something, it's his or her responsibility for maintaining your code. So basically, author have no responsibilities at all after contribution is accepted. That's why it's really, really difficult to get an attention of the committer. Because if your patch has some bugs, it will be committer who is fixing these bugs. Even if you provide patches, the committer has to review your patch, assess it, and say, okay, if there are new bugs in your patch, that's on me. Usually we have 1 or 2 new committers per year, and some are retired recently to past committers. Here are some examples of committers, but let's go. Today we have a process that is called commit fest. Commit fest is an application which tries to organize development during a specific month. So this is a picture from January commit fest in 2024. You can register a patch there, and if you register a patch in a commit fest, it's expected that you will review someone else's patch. This is kind of a way to balance reviewers and patch authors. But reality is that usually patches to be committed need more than 1 review. So if you have some spare time, you can contribute not to writing code, but just open a commit fest application, pick a patch that looks interesting to you. I advise you to pick my patch, of course, and try to review it. Apply this patch to sources that you have just cloned, run the database, and try new functionalities. That's the best review. Actually, reviewer has to answer a simple question, like why this should never be committed. I'm putting in very strong words because negative feedback is most important. It's very easy to say, it looks good to me, this patch is great. It's easy to understand why new patches bring a value, why they are kind of wanted. But the reality is that Postgres is used by millions of developers deployed across millions of servers. And it's a bad idea to give someone a value, but break something for someone else. Actually, reviewers and committers are very, very cautious about breaking something because we have to make the database very stable for existing customers, for existing users, that's why we actually critique is the most important part of review, not just finding what is good in the current patch. There is a commit fest manager. There's a role for someone to see that the patch is not moving on and says that it seems like this patch received enough attention and it's time to withdraw it from commit fest, or if it's necessary to move to the next commit fest. Essentially, commit fest manager is trying to organize and make things moving so that we don't have too much of a stale test where nothing is happening. Next part of our development tools is a build farm. Well, in Wild it's called continuous integration, but we call it build farm. This is just a number of machines that run different operating systems on different architectures, and they run tests of Postgres with different settings. And that's another way of contributing to Postgres development is creating your Postgres build farm animal. We call them animals, and they have animal-like names. So the animal is connected to source code repository and constantly running tests and reporting these if something is broken for your platforms, sometimes we are asking if what kind of operating systems are supported by Postgres. Like, obviously, there are many various flavors of Linux. Which one? How to decide if this kind of Linux is supported by Postgres? Very easy. If there is a build farm Linux machine for this kind of Linux, then this Linux is supported. If it's not, then it's not supported. So, if you have your distribution of Linux, create the machine and attach it to the build farm. That's relatively easy. Really, it can take up to half a day to configure your farm anymore. Development cycle. Well, if you contribute something new today in August, we will have a feature release in April, next April 26th, and source code will be released by September of 2026. So normally, if you have an idea for new feature, you will have a production ready implementation in a year and a half. So it's not very fast development, but we really want the system to be super stable. We have a stable branches for supported versions. Normally, we support 5 released branches when there is a new version, and with next minus we sunset one of all oldest versions. So if you provide a patch that is fixing some issue, it will be committed in many branches for many supported versions. We almost never pick features to stable branches because we want people to upgrade. We want, like today we have a lot of folks around the world who run Postgres 8, Postgres 7, and this kind of a problem because we cannot fix them all. If we encounter some critical bugs, we fix it only in 5 versions. So if your database is more than 5 years old, consider upgrading to a new major version. Currently, you can have almost upgrade almost without downtime. On stable branches, we have text for releases. So if you are not sure that you are running some version, you can compare the source code to text that is sampled by core team members. Every 3 months, we have a minor releases, and most of the time there are some vulnerabilities found and fixed. So I really advise to do minor version upgrades in few weeks after they were released, because like any software that have a lot of attention, we have some vulnerabilities that are found and need to be fixed to ensure security of the database. On commit test, usually patch is not committed right away. Here is an example of some track of my feature. So it was proposed in 2019 and committed only in next version. So I proposed in autumn 19 and it was committed in September of 2020. That's normal. Sometimes features that we propose are discussed for years. That's something to be prepared to, and well, we need every patch needs to have enough attention of reviewers, and every time it's moved to next manifest, pick something else to review. So that's how you ensure that patches of other community members receive enough attention, enough reviewers' attention. Well, working with Postgres code base is mostly working with Git. Normal flow of working with the code is like creating a temporary branch derived from master branch, hiding something on there, committing something to your personal branch, and formatting here I have formatted 7 previous commits with a version from here. This last comment, patch format will are sent to mailing list. We'll do it later. Easiest way to run tests is not running tests on your personal machine, but to use GitHub CI. If you commit something to your personal fork, for every commit there will be tests run on Linux, macOS, Windows, and various flavors of Windows and Linux. Usually it takes from 5 to 10 minutes to run tests on all platforms. I was working on many different databases, and anywhere else tests were running for weeks, or at least for days, or at least for several hours. I'm very proud of this community that we can run all tests on most of major platforms in 8 minutes for anyone in the world for free. You can produce 10 patches a day and still run tests for it, and it will cost you nothing. But well, you can run minimal tests on your machine in 30 seconds, and I will show it to you later. Here is an example of a message to hackers mailing list where I attach 3 patches, like a series of 3 steps, some description, and typical work on your patch that you will send. Previously, is rebasing your patch on the new version because development goes on, and if your patch is not committed, you have to rebase it. When you're writing a message to mailing list, remember that you're writing for an archive. It will be a website for decades. A lot of folks will be reading your message later. That's why, spend some extra effort on proofreading what you're writing, because it's there almost forever. It's usually plain text messages, and sometimes we are asked not to do a top posting. Like if you're answering a question, you quote a question and then answer below, not vice versa. And sometimes you see a lot of critique to your patch, and that's great. It's the best thing that you can get, because a lot of folks can say how good your patch is. That's not of big value to you. You know that that's the problem that you are solving, that it's important. But the real defects in your patch, that's what you want from a community. And when you receive a critique, it's great. That's like you are not your code. It's not a critique of you, but of a patch that the community wants to get merged in. That's why you get a critique. We have a ways to contribute besides Postgres. We have thousands of different extensions, and usually contributing to extension is much easier than committing a patch to Postgres core. And I usually maintain it by a team of 2 or 3, maybe like 5 hackers. That's why we can find much more defects in extensions. Meanwhile, it's exactly the same code base. I mean, the code base of extension usually lives on the same rules as the core. So you can change something in extension, learn how to do it, and then later proceed to the core. There are many widely used programs that tools the company database, like high availability system, backup system, and they are good if you want to try yourself on different programming languages. So writing extensions and writing core is a C programming language, like C89 extension. But if you are good at Python, you can contribute to Java, or you can contribute to Percona. If you are good at Go, your PRs are welcome in OG and other Go projects. How to start? How really to start? The easiest way is to watch my video on YouTube, but I will repeat it just for you in a few minutes. There is a hackers mentoring program, but essentially this mentoring program is expecting already experienced hackers. Another good idea is to subscribe to mailing list and from time to time read it. You don't need to read everything, just read something that's interesting to you because as you your niche. Find something that's interesting to you. Pick something for you and your test. Go to conferences, but you're already out of conference. What are real difficulties in code contribution? It's hard to set a goal if you want to, if your employer want to pay you, they have to distinguish if you are contributing more or less. But you cannot guarantee that something will be committed. And producing patch that is working doesn't seem like a meaningful goal. You actually want to deliver your features to users. That's why it's, from my point of view, maybe Peter will agree, it's difficult today to start a career of open source developer in Postgres unless you have a very deep experience with writing useful programs in other projects. Code base is very complex and well, it's just all too many lines of code. There are 2 million lines of code, and unlike in operating systems, operating system is very modular. You have a scheduler, you have a file system, you have memory management, you have drivers, and so on. But the bases are very, very tightly connected. You have to understand the picture. And this is a big problem to start. You have to understand indexes, locking, storage manager, buffer manager, all that stuff that you don't even just use Postgres. And that's a big problem, learning curve is too steep. And we are using instruments that probably you will not meet anywhere else. Like we use C programming language. How many positions do we see for C programmers now? We use Perl. Like it's a write-only programming language. I don't understand most of my code that I've written for Postgres in Perl, but I tried really hard. What are real opportunities? Like if you have a big server, big service, it costs you like hardware, software, and salaries of engineers. But that's not exactly true. I have a theory. It's not proven yet. So let's say you operate a service that is used by millions of people. You are operating something useful. You have to pay something for licenses and to your SREs. You have to pay engineers who oversee that everything still works. There will be some incidents. Like something will get broken and users will be upset. Someone will stop paying you, someone will, it will cost you money. Usually not directly. Usually you have first PR costs and then it translates to money. And you pay something for compute power and storage power and all that stuff. You pay something for servers, you buy computers in some way. And here, so basically you have here boxes cube, dollars insert in power 3. And here we have a measure of how compute intense your service is, so you can account for number of queries, that's bandwidth of traffic and so on. And I think that's some universal constant of symmetry. I'm not sure, I can't still can prove it, but the more you pay to go SREs, the less you can have compute power. The less you have compute power, the more incidents you have, and so on. You can try to adjust one part of the equation and then get changes to another part of your equation. And that's where the real reason to contribute to Postgres arise from. Your contributors, your engineers who understand code deeply can help your SREs in a very edge cases and severely reduce your incidence costs or computation power costs. But building way to interact with contributors is very difficult because you need someone who have almost infinite credit, like who is trusted that contributors are doing something good for their production. And for this to build this process, you really need not just a person who is trusted for doing good for a project, but also you have to have a very big service. So I don't observe that much teams of contributors who interact with this release. And contributors who are working mostly on their ideas and their minds don't have this feedback from a production. So their ideas might be not that useful to really users. So you need so basically there must be some company who pays for development. Today I observe like I may be wrong with this. I mostly assessing like a labor market. Who can pay me for working on Postgres? And there are some companies that are doing Postgres only. Only companies who are developing Postgres and only Postgres. There are a lot of big contributors in hyperscalers and clouds. These two are like enterprises. Not too many folks actually want to do their career in enterprise. If you want something startup-like, there are a lot of startups who have some great ideas and they build on top of Postgres. They only want for reasons, but anyway. This list changed. So this presentation was created like half a year ago. Now this list can be extended and shortened in some versions. But you always can keep a startup who wants someone to contribute to Postgres code base. And there are a lot of new companies here. Most common way to exit is just to be acquired by a very big company with billions of dollars. And there are users who are encountering problems with their customers at scale, like Percona, Yerevan, and I see a lot of contribution from these teams. Probably this list is not exhaustive. Anyway, I think it's time to have something. Oh, when do we have? How many time do we have?
Around 10 minutes.
Okay, we'll try to do it. First thing that you need to do is to configure your installation, and you have to specify where Python compiler binaries will be. By the way, the biggest problem with Windows developers is that they expect this to work in Visual Studio, and this doesn't work in Visual Studio.
Can you move it to the top of the screen, please?
Sorry?
Can you move it to the top of the screen, like here?
Probably so.
Or like here, the screen,
Okay, so and essentially you need to configure, say where you will have your compiled version of Postgres, and that's another flag that you just need. I usually type conf. Well, I need to go to clone Postgres and then run configure. Okay, now it will find the compiler, find like libraries, connect to all the subsystems in operating system, and get prepared to compile stuff. To compile stuff, we can run make specified number of threads, and also I will say install. It will take about 30 seconds maybe. If my laptop is not very hot, it should be fast.
The impact is there between linker and settler to kind of format insert and conversion method for certain linker, let's say you are right what to format
Yeah, we have a page we have a formatting tool which is called gindent, and it's built into sources. So you can, when you compile it, you can run gindent against source code, and it will reformat your code. So don't worry with formatting. So we just installed Postgres. Now we have this bin folder. Here we have all our programs that were compiled from sources. We can, first I will stop all Postgres on my machine, never do it in production. I'm running initdb to create a new cluster. And starting this cluster, gctl, saying the cluster is in folder test something, start. It started, and I'm connecting with PSQL. Folks are asking if it's a good idea to connect the development version with data grid or here. It's okay, or pgadmin, but for development purposes, it's easier to use console tool. So now we have select one. Okay, let's try to hide something. Open the code in code editor. I want to propose a feature like normally you are writing a query that is selecting something from table. Select code name from table. Like let's try it. Create table x plus select I from generate series 1 to 10. Right. Now we can run select I from x. It's 10 numbers. Or we can use more ancient versions. It was pre-standardized table x, essentially the same, selected numbers. But now we want to implement a feature like writing table first and columns later. From x, select columns. It's not supported. And it won't be ever supported because it's not, well, it cannot be supported because it's not in SQL standard. If it will be in SQL standard, it will be Postgres. But if you really want, you can hack it. You can have your version of Postgres. So let's open sources. Code. I'm using Visual Studio Code, like you might want to use Vim or something else. Essentially, just in the text editor. You can find a grammar in gram, file gram.y. Yeah, yet another compiler of compiler. It's Yak. Yak basic and Bison basic. Here you can find simple select. Here is a cool simple select and see what it's made of. It's made of literal select. option clauses, target list as columns list, inter clauses, from clauses, and so on. And we want this from clause. Let's find it here. We see from clause is a word from and a list of tables, table references, which can be some queries, but let's not go that way. Let's just see this from and define a simple select. There are different versions of simple select. This version, select is distinct, and our table version. So let's just copy this part. Now we defined two times similar syntax. Let's modify it. Say from how it was called. Anyway, from target list select. And also we have to renumber stuff here. So basically target list is number 2 now. Inter clause is 1, 2, 3, 4. Inter clause is 5, I think. If anything goes wrong, I will just renumber it again. 8, 9, 10. So we modify the grammar a bit. Let's try to build it. Make, if we say minus s, it will print only words. We see some login from running the base, which is running in the same console. So its login is attached to the large output of this terminal. It seems like it compiled, make install.
There's an error to it, okay?
Huh?
There's an error.
Oh, there. Actually, yes. So it's a problem. Some conflicts. Should we do something? We did something wrong here. From is not target list. From is. Okay, thank you very much. It would be a big problem if we try to test it now. We also missed something in our renumbering, and it is related to inter clause and from clause.
The target list.
Target list is actually 5. Inter clause 5, 6. Inter clause 6. From clause. So it's just a number in this list. Let's try to make it again. I hear it. Install. Let's go to our binaries. Restart database. Restart. And connect database with PSQL and run this from. It works. But it's not enough. We want to be sure that we didn't break anything. We want to run tests. We type make check. Let's see the tests are running. And also format patch. While tests are running, I want to say, so those who clone on Postgres, try sometimes you encounter some problems that they are all solved. We want to format a patch, so if you see what we changed one file, added something to remember. Git commit. Most important part is writing your commit message, and I'm not very good at it. Like, I will write some clever commit message. Most of Postgres commit messages are multi-line, and they are explaining what they've changed. But not right now. Okay, so I committed. We now see in the log our changes made today and use a quick message, not very strict. And we can click format patch for one commit. Here, this is a patch that we should send to mailing list for discussion with hackers. Basically, that's it. Try this hacking on your laptop, and I will be happy to help you. Thank you very much for listening to our